Good morning and welcome to this morning's webinar. Today's topic, we're going to be diving heavily into microservices. And my name's John Wetherill. I'm technology evangelist at ActiveState. I've been here for about 2.5 years, diving heavily into all things cloud and PaaS related. And so I've done several of these talks on these OpenStack webinars in the last few months, and had a fair number of requests to talk about the topic of microservices, which is certainly a trending topic these days. So today we are going to talk about a number of things, a little bit of background on what the evolution of this whole microservices thing is, and then describe what they are, some of the benefits they provide, some of the challenges that organizations are encountering when they're trying to adopt a microservices approach. We'll look at some of the evolving practices and things like testing. We'll talk a little bit about DevOps and talk about PaaS. So, and just before I get started, I really need to call this out. I just got back from an event in Santa Clara, the Cloud Foundry Summit. And the reason I'm bringing this up here is because of the momentum these days behind a number of areas I've mentioned, but things like containerization and Docker, continuous delivery, platform as a service, infrastructure as a service like OpenStack, Internet of Things, IoT, and finally microservices. It seems all these things are converging in a big way, and organizations are really waking up. And this conference, I go to a lot of cloud conferences, but this conference this week, the Cloud Foundry Summit, a lot of things really came together. Companies of all descriptions, from companies that sell paint or chicken sandwiches, or large religious organizations and insurance companies and financial institutions, you name it. Every company, government organizations, like the large, like the immigration and naturalization services, people like that, they are all rapidly moving towards a microservices approach, and they have to. And everybody I talk to, almost everybody I talk to, is plugged into this and moving towards it. And hopefully throughout this webinar, it'll illustrate some of the reasons why. I will be tying it somewhat to OpenStack, and I do want to say that infrastructure as a service is, among others, one of the key enabling technologies that's allowing the adoption of microservices to happen effectively. Basically getting helping eliminate the process of delivering successful software. So with that said, diving in here, talk a little bit about monolithic applications. They've been around for years. That's how we've been building applications, the typical 3-tier application where you have the back end, the persistence layer in the back end storing all the data. The middleware tier, kind of the controller tier, let's say, and then the front end tier. And it's a natural way to build web applications, and it's worked very successfully for years. And there still are reasons to build monolithic applications. But there's some big downsides. So there's a ton of internal complexity. If you've ever worked on a large enterprise team building out these software, you have very large teams. Let's say typically, in this case, 3 teams, one responsible for each tier, and they have to coordinate. There's a lot of coupling between these teams, a lot of communication, a lot of meetings, and a lot of overhead. And typically, the monolithic apps are packaged as a single entity, and they then are deployed out to production using a large, complex, and time-consuming and costly process. So, for example, it's not uncommon for an organization to take months to push out a new update of an application, weeks or months, and it often has to go up to VP approval, things like that, just to get let's say you even need to make a small user interface change. Huge amounts of work. It usually has to go through the whole QA cycle. We're talking weeks, months, several months, who knows. And it's not very amenable to agility and disruption and getting evolution and innovation. So it is worth saying though that there's still big use for monolithic applications, and if you're starting up building a product, or let's say a startup, or trying to a proof of concept, monolithic app is the way to go to start off with. While you get your code out in front of your customers or your users, you can evolve the requirements because, as we'll see shortly, microservices approach is complex in its own way. The complex doesn't go away by any means. It's kind of just moving around and getting compartmentalized, as we'll see. So that's sort of a brief discussion of monolithic apps. I'll get back into that a little bit later. Let's look at some of the benefits, though, of microservices, and while we're going through this, I'll describe what we're talking about here. These benefits illustrate actually what they are. So with a microservices approach.
Hey, John, sorry to interrupt. Your slides aren't moving forward, so I just wanted to make you aware of that.
Oh, thank you.
Okay, sorry about that.
Right. No, thanks for letting me know. So I apologize to the audience. My slides you were just looking at that monolith for the last 2 minutes. So this is the slide that covered everything I just discussed right now. I'll let it sit there for a sec while I move on and just briefly introduce microservices, where instead of having these large monolithic applications, you basically break up your application into a number of loosely coupled services that each have very precise functionality, kind of a precise context.
John, so I'm sorry again, we're not seeing a change. Can you check? It may be that we're seeing the wrong screen. I'm sorry.
That's okay. Do you see the? Oh, I see. Look, let me try this now.
There we go. Perfect. Thank you. And I will go back to being non-existent.
No, that's fine. Thanks. I clicked the wrong button on the presenting tool. Okay, so now we should be good. So so now I suspect you haven't seen any of the slides, but I guess that's fine. We'll continue where we left our. So back to the discussion of the microservices. So with microservices, as I said just now, we break up the application into a number of small, independent services they're loosely coupled, but they intercommunicate, or at least they provide a means to do so. And what this means is, instead of having a massive team responsible, or massive teams responsible for this large monolithic application, you can break up your teams into very small focused teams that are responsible for a single microservice. And then those microservices are then able to communicate to other microservices or other services via an external, a published, exposed API of some sort, whether it be a RESTful, HTTP-based API, or a message queue type thing, a messaging system. But this provides some very significant advantages to the overall system. So, for example, you can. So, if you go to a typical enterprise today, go to a lot of organizations today, they standardize on a single stack, a single language, a single database, a single framework. So, let's say Java and Spring and Oracle. And if you want to build out your application, you have to use all of those technologies, or that's it. So if you want to bring in some new functionality to your application, you have to build it in those tools or those languages and frameworks. And there's a lot of things out there that might be better suited for, let's say, JavaScript and MongoDB or Ruby on Rails or something like that, using Redis. There's all sorts of powerful tools out there, but when you standardize on a single stack, you don't have that ability to just choose the appropriate stack for the job you're trying to solve. Whereas with microservices, they're completely independent of each other, and one microservice doesn't care at all what language and tools or stack the other microservices are built with, because they just interact with it via a published exposed API. So it gives you a lot more flexibility. And another related thing is a lot of companies have disparate teams. Maybe some teams are very proficient in Java, other teams are more proficient in Ruby. Sometimes it's better if you have a small Ruby team, maybe you got it from acquisition, to have them continue focusing on Ruby instead of moving over to Java, which they might do kind of grudgingly. So another very important feature of the microservices approach is that each one of these services can be updated independently. Very important. And it means that the update, instead of being this massive jar or WAR file or jar file that needs to be deployed, it could be a very small component. And this ties in really nicely to the whole continuous delivery concept, where if you have very small targeted updates, you can push them out, all the time, multiple times a day, multiple times an hour, if your processing and tools are in place. So as you can imagine, this considerably improves the agility and ability to deliver software and innovate, basically. Another important benefit is it empowers developers. So in the old days, or I guess the current days for a lot of organizations, if a development team needs to get something done, they need resources, they need to deploy code, they need to access or get a database set up, spin up. There's a lot of process in the way, and it's kind of a dangerous setup where the developer team has to submit service desk tickets in order to get resources made available. And oftentimes, there could be days or weeks or even months between the submission of the ticket and the acquiring of the thing they're asking for. And as you can imagine, the innovation and the creativity and the flow just goes out the window when this happens. Everybody's used to it. It's how it's worked for years, but it doesn't help with the innovation. If you can empower the developers to push basically to production, it does a lot of things. It gives them great power. It gives them great responsibility as well, and they're actually more incented to make sure that their code is more, is even more reliable and everything, secure and everything. So, empowering developers is a very important aspect of this. The rapid delivery cycle, I've alluded to that. So with these small targeted services, you can update them in short order and push them out in minutes or hours instead of months. And also, it enforces strong design. Sort of instead of a hodgepodge of everything intermixed in the monolithic approach, you really need to carefully consider your design where you're separating your microservices out, what has to be done where. Excuse me. And so at the end of the day, if you've done it right, you have very loosely coupled and very isolated components that do what they need to do very well. So there are challenges involved with this whole thing. It actually, as I said earlier, the complexity doesn't go away, and arguably it actually gets more complex because basically we're building a large distributed system now where these microservices can reside anywhere on the network, anywhere in the world, really. And for example, it's common to be using microservices from other vendors, other organizations as well. And so we're introducing some of the complexities of distributed computing into the stack. It's worth the payoff, though. Excuse me. Okay. Another challenge to microservices is conceptualizing the complexity of the stack. And I wish I had one of the diagrams with me, but I've seen the architecture diagrams of the microservices from various companies, like Netflix is the best example, Halo, and a few other ones, where you have hundreds, perhaps 500 or 600 microservices all intercommunicating. And if you look at the diagram of that, it's basically just black ink on paper, basically lines drawn between all these various services. So far, the tools that are available to understand and conceptualize and visualize the relationships between microservices, these tools have not evolved very well. So that's coming. People are working on it, but it's got a ways to go. So related to that is the tool sets in general haven't been evolved. And I'm just getting a comment that the slides aren't moving. Oh, yes. There we go. I'm having technical difficulties, but I just realized why, so that shouldn't happen again. Thanks to the attendee who pointed that out. Okay, so now we should be in the complexity slide, the challenges slide. Where was I? Immature tool sets. So yeah, the tool sets haven't evolved very well to work with microservices, but I will say that that's rapidly changing. And part of the reason for that is there's so much momentum behind microservices that the tools vendors are working really hard to make sure that microservices are fully supported. And a good example of that is platform as a service, which I'll get to later. One of the more significant challenges with microservices is culture shock. And maybe just talk a little bit about Conway's law, which is a law that was put out a few years ago, or stated a few years ago by some guy called Conway, where he states that the architecture of your software architecture basically reflects the organizational complexity. And which means that if you have a large, complex organization with lots of dependencies and complex communication and process, your software is going to end up looking like that. And in order to successfully deliver a microservices architecture, you'll need to kind of invert that, where you need to decide how your software is going to look and then reorganize your organization to reflect that. And changing an org chart is really, really hard, much more difficult than changing a software stack or a tool set. So there's a lot of, if you go to a DevOps conference these days, half of the talks are on tools and technology, and the other half are on culture change. It's a very significant shift that companies need to deal with to move into microservices. I'll say a little bit more about that. And then finally, as is with almost any new technology, when something's new, it's often difficult to find experienced developers and DevOps people that have actually had experience building software. So, okay, slides should be moving up. So let's dive into some of the practices that are related to microservices. There's a pattern called immutable code service patterns. And this is a very powerful concept where, and it's something that microservices enables, where if I push out a microservice and it's responding to requests over time and responding to all sorts of requests throughout the day, and then I need to make a change to it, I can push out a new version of that service and leave the existing service operational. And then there's some mechanism to swap between the various versions of this service. And or not, or maybe when I put out the new version of the service, I can have other services that need to call it, just call the new version of the service. But it means the old version is still there. And this is very significant. If there's a problem with the new version, you can immediately, with zero downtime, roll back to the previous one because it's still there. Whereas you can imagine with a multi-gigabyte WAR file, there's no way to do things like this. You can't just instantly revert back to the previous version. So often in a microservices shop, you'll find multiple versions of a microservice running perhaps for all of time. And given that they're small and easy to deploy, that's not typically a problem. The next thing that you have to be very aware of is, it says here, avoid trunk conflicts. Basically, the concept there is that in your source code management system, you want to make sure that that you have every microservices completely self-contained, and you don't share multiple microservices across a repository, a source code management repository. So when you make updates to one microservice, you're not making any, you're not affecting any other of the services that you're maintaining. And the way to think about this is almost as if you could consider that a microservice is being developed by an external company. Let's say you're using Google Geo-encoding service, which is a microservice which is available over the web. You kind of think of it that way. If I'm using that external service, I have no visibility into it. I don't have access to the code. I don't meet with Google if I want to make a change or ask them for a change. I just deal with what they have. And certainly there's no conflict in the source code management repositories. I've got mine and they've got theirs. And you basically take that concept internally. I'm going to get back to the third point here, respect attention plan shortly, but I want to move right away to the break things deliberately practice, which Netflix in some ways, I don't know if they pioneered it, but they've certainly brought it into the mainstream with their Chaos Monkey. So when you have a complex architecture like this, in order to make sure it's available and reliable, you need to deliberately break things as much as possible in order to invoke whatever recovery mechanisms you have in place. Basically you're designing for failure. Google's been doing this forever, assuming that there's going to be some percentage of failure. It's the same thing with microservices, and Chaos Monkey will deliberately crash services or return arbitrary responses, error codes, or introduce network latency, things like that. And the point is, if you do this deliberately while your software teams are, let's say, at 10 in the morning when they're awake and fully caffeinated and expecting it, they will know how to, they'll see how to respond to it and recover everything. Much better to happen in the morning than at 3 in the morning when everyone's asleep. And over time, if you do this consistently, your system gets much more resilient. A very important point is no manual anything. Pretty much everything needs to be automated. If you have to invoke some manual human intervention in order to deploy a microservice, then you're losing a lot of the benefits of this approach. For example, I'll just pick on logging. Logging is a good example. So when I deploy a microservice, if I need to manually invoke some external logging aggregator or manually wire up the service to the log aggregator or anything else like that, if there's any human intervention, that's going to change the deployment time from potentially seconds or milliseconds to minutes. And it's also going to introduce human error. And it also means that there's, you have this human dependency, this manual process dependency. This has to be eliminated completely from the top to the bottom of the stack. And we'll see some of the techniques available later that does allow for that. Finally, a very important evolving practice is this practice of creating and curating your access libraries. So I mentioned earlier, every microservice has an exposed API, published API that's used to communicate to the microservice via other services or other consumers. Doesn't matter what they are, applications or users. So these APIs can be made available. If you only make the APIs available, however, the consumers of the API, the clients, the customers, will be forced to write their own libraries that wrap the consumption of the API, usually consuming a REST API. It's straightforward to do so, but it's a little bit low level and complex. And you always want to combine these and wrap them in some sort of access library or some mechanism, or some tool or command line tool or whatever, plugin. And if the writer of the microservice doesn't do this, then it forces the client, the customer of the microservice, to write their own access libraries. And then, as you can imagine, this causes fragmentation and different versions of libraries all over the place. And ideally, it should be the provider of the microservice that creates these access libraries and make those available. So not only are you making the API available, you're also making the access libraries available for the consumer. So Okay, next we have, I'm going to skip over the testing slide because I'm looking at the time and it's going by pretty fast. I do want to talk about the deployment and DevOps world a bit. In order to successfully adopt microservices, you must adopt a DevOps mindset. And the things to focus on here is, as I mentioned earlier, we need to invert Conway's law, where you have to organize your company reflecting the organization of your software architecture. And what that means is, as we said earlier, microservices implies small, focused teams, each focusing on a specific service. And what it means is that team is responsible for the entire stack, top to bottom, from the user interface, if there is one, or the API, which there probably is, the middle tier, if you want to call it that, for this microservice, and if there's persistence, or if it's using other components, message queues, anything like that. The entire team has to be responsible to manage this whole stack. And compare that with the monolithic world, where you have your DBAs, the DB admins that are responsible for managing the database schema. And if I want a new schema created, I need to submit a ticket, and they add that to their queue amongst the millions of other things they do. The database folks have no idea. They don't care what my app does, my service does. They're just focusing on their database schema. And that basically has to be inverted or completely changed, that is, so that every team is fully responsible for the entire operation of that microservice and is fully capable of building it, designing it, of course, deploying every component of the stack, the testing, everything is part of the single team. So a small targeted team that is responsible for top to bottom of this microservice. And then over time, your organization needs to accommodate this kind of organization. I said it earlier, but process needs to be eliminated. So, and I said also automate everything and eliminate service desk tickets for sure. So no tickets you should never have to submit a ticket to request a VM to be spun up or a database instance. All of it should be happening. Another way to look at it is you're taking your IT ops and you're not eliminating ops by any means. It's still essential, but you put them behind an API. So the ops people are responsible for making sure that the API makes the resources and the processes available to the development teams. And there's no human being that's required to read a service ticket and submit another 25 service desk tickets, etc. So again, I can't emphasize that much, or I can't emphasize that too much. Eliminate process. I have seen organizations trying to adopt microservices that retain their ticket submission system, and it just does not work. So that kind of has to be a high priority goal. Jeff Bezos from Amazon coined this 2-pizza team rule. What that means is just basically your teams can't be that big. You can't have 50 people on a team. Your team should be small enough that 2 reasonably sized pizzas can feed them. So another way to put that is probably under a dozen people to manage a single microservice. And they're all very, very well connected and understand what they're all doing. Another aspect of this is as we said earlier, developers are empowered. They need to be empowered. In the old school, the development team would build a application or a service, whatever they're building, and send it over the wall to the deployment team, and the development team then moves on to something else once they've decided it's shippable. So it goes to QA, goes to the deployment, it's done, and then there's a maintenance team usually involved or responsible for maintaining the code, and if something breaks, the maintenance team deals with that. Developers rarely hear about problems with shipped software. And in the new approach, that's not the way it is anymore. Developers need to be fully invested in their code for the whole lifetime of their code, basically until the code is end of life. And the developers then are responsible. If their code breaks, they need to be available to fix it. or at least this is a common approach. And it has some advantages. The developers are much more invested in making sure their code is correct. If I know that I've got a pager that could go off any time of the night, I might spend an extra few minutes at the end of the day just to make triple sure that that code is not going to break. So that's another important consideration. As you can imagine, these things, they're difficult for organizations, but the payoffs are huge. I also should mention, I forgot to earlier, but if there are questions that come up from any of the attendees, feel free to type them. You should have access to a chat window, and I'll get to them. So I'm going to just quickly dive or jump into some just other common practices that are helpful if you're considering a move to microservices. I've been going to a lot of meetups and talking to a ton of organizations that have adopted microservices, and I've really been looking at some of the best practices for making it work for an organization. So one of the pieces of advice I hear often is if you're considering microservices, dive right in. And what that means is identify a small team, or even could be just one person, that takes a small component and just starts building a microservices-based application or service that can maybe be incorporated with the rest of your stack at some point. It's often best to find a small project that doesn't have too much, it's not too important to the success of the company, maybe an internal app or something like that could use a service. But dive right in and get it moving. And similarly, start small. So don't think you're going to rewrite your main corporate application on microservices in short order. Instead, as I said, just find some small project, move that fast, get it moving, and so you can very shortly see the benefits of using microservices. It's also helpful to identify external microservices and basically services available from third parties, from other vendors, that you can incorporate into your existing applications. And chances are you already do that. I mentioned earlier the Google geoencoding service. There's tons of things. There's Dropbox. There's all sorts of external services and providers. There's gazillions of these things now. And the point here is, if you take advantage of these external services, it's the same mindset as your internal microservices would be, in that the teams, after the API has been fully decided on, the teams don't need to intercommunicate. They're responsible for making sure the API is responding as per spec. And so just like I don't have direct access to the team inside Google that writes geoencoding, I wouldn't need access or to spend, interrupt the time of the internal team in my company that has some service that I'm relying on. So if you get into the mindset of using and accessing these external microservices, it helps with the transition to move towards internal microservices. This is a really important point. I don't know how many companies I've seen or even worked at where there's slight differences between the various stages of the development cycle. Development versus test and QA and production staging. If there's any differences in here, it's only going to cause headaches, and they can be dangerous headaches. So what you want to do is make sure that every one of these phases is as aligned as possible. There's no configuration differences. There's just basically no differences between any of these. I've even seen when there's developer one in an organization, his or her setup is different in just a slight way than from developer two. And it can cause tremendous agony. There's tooling available that really helps this out, as we'll see shortly. I mentioned this earlier, stewarding or curating your access APIs. So make sure that when you have an API for a microservice, you wrap it in a library and make it available, make that library or tool or whatever it is available to the consumers to standardize on the access. This is important, and this is something that's often overlooked, is when applications are designed and built and delivered over that life cycle, the reliability requirements, the availability and reliability and all that, tends to be left towards the latter end of the life cycle. And that's not the best approach. Instead, identify these requirements as early as possible in the life cycle. How reliable and available does your application need to be? And then design and build and test those requirements as almost from day one, really. So that even if you push out a simple hello world application, it's just a panel with a button that says hello world, maybe puts an entry in a MongoDB database, get that as reliable, 5 nines reliability, whatever it is, however you're measuring that, make sure it's as reliable as your end product needs to be. And then throughout your entire life cycle, you should always be testing for that the reliability is retained. Tooling helps with that as well. I mentioned this earlier, get rid of all IT barriers, no service desk tickets anywhere. I implied this slightly as well, but with microservices, there are situations where you might need to keep your microservice active for all of time. And some examples might be if you have external clients of these microservices or these services, maybe devices that are out in the field that cannot be patched or changed or replaced, then they might be calling into, relying on some of these services for all the time. And with small, isolated services, it's not that hard to accomplish this. I said earlier, they're not these multi-gigabyte WAR files you're deploying, so you can actually keep several of them around. So the point is just to keep this in mind while you're building out your architecture. And so when a microservice when it's been delivered, again, this is the whole concept of the developer is still retaining control of the service, retaining ownership of the service even after it's shipped. So they don't just ship it over the wall and leave. So as far as the developer is concerned, it's only fully complete for them when it's actually when the service is no longer operational. So they're still vested in this microservice for its entire life cycle. Fail fast. This is the chaos monkey idea. Again, I need to emphasize this, that introduce failure as early as possible and introduce mechanisms to recover from that failure. So it's second nature. Just like, as I said earlier, the Google data centers, they expect some percentage of their servers to always fail. So they don't try to prevent failure. All they do is they implement process in order to make sure nothing globally fails if an individual server fails. And they've done a fine job with that. When you're building out these microservice architectures, consider the requirements for synchronous versus asynchronous services. Typically, in a system like this, it's the synchronous services. A synchronous system introduces certain complexities and difficulties in testing and also performance issues. And so think of this hard when you're designing your architecture. And ideally, you want to minimize your synchronous services as much as possible and try to keep things asynchronous. And it tends to allow for less complexity and more scalability in general. Obviously, this is a topic we could spend a whole webinar on, but it's worth considering. Feature flags are useful. Feature flags are toggles that you enable or disable to enable or disable certain functionality of your application. So it means you can have your code pushed out which has a feature in it, but it actually never gets invoked until you enable this feature flag. And when you enable the flag, subsequent calls to the service or whatever it is, the user interface that feature will then be enabled along with it. And that means that if something breaks, you can disable the flag and the feature is no longer invoked. It allows you to more rapidly evolve your product or make it more flexible and more configurable. So it's a handy thing to consider or use with microservices. This is an important point, and this is now where I wanted to talk a little bit about the infrastructure. So obviously, this webinar tends to be focused on OpenStack, so it's an important topic here. The development team ideally should not have to concern itself with the plumbing, the underlying plumbing. So much time is spent today like I say, it's in the weeds. You're dealing with the underlying complexities of the infrastructure and the systems. And ideally, a development team shouldn't have to worry or care. Instead of writing to a specific infrastructure or specific architecture, VMs, etc., the development team should almost consider they're just writing their app for the data center. Writing an app for a data center should be the same as writing for the laptop, and they shouldn't care. I shouldn't care, and I shouldn't have to make any changes or do any configuration to build my app for the data center or multiple data centers as I would for my laptop. And currently, that's kind of a stretch, even with infrastructures like OpenStack. There's still a ways to get there, and so shortly we'll be talking about ways around that. But I can't emphasize this too much either. The need to the development team should be shielded as much as possible from the complexities of the infrastructure. Okay, I'll emphasize again, if you have any questions, feel free to send them out. This is an interesting concept. With microservices, I mentioned earlier that each service would have its own database or persistent data store if it needs it. It's a common mistake to build out all these microservices but still retain a centralized, let's say, Oracle database or SQL database or something. And what that means is that these services are not as loosely coupled as they really need to be. There's dependencies on the schema, and it means if you need to make a change to the schema, add a column or shuffle things around, it could affect multiple services. So instead of that, what needs to be done is each microservice should be responsible for maintaining its own data that it needs, or abstracting that out to yet another microservice that maintains that data. And sometimes this is a little counterintuitive, where you might have data that's duplicated across multiple microservices. And there's nothing inherently wrong with that. You just have to design for that and understand that this is an approach that you might have to deal with. But you need have to get out of the mindset of sharing data across multiple services in a single database instance. Okay, so I should mention there's tons of evolution in this area right now. As you probably know, there's tools that are evolving, lots of practices. Some of those I've tried to capture in this webinar. There's patterns that are evolving, circuit breaker and things like that you can use to help build out your microservices architecture in a way that will be resilient and available and all that stuff, scalable. So it's important to keep on top of this as much as possible, and there's conferences and webinars, etc., that will help with this. I will provide a link at the end of this to some useful material. Okay, this is a really important concept. If your organization is moving into a microservices approach, it's very common that there'll be a small number of people that are supportive of this, and obviously it would be helpful to move it across the whole organization. So early on in the adoption of microservices, identify metrics, things that you can measure that then you can, after you've successfully deployed a couple of microservices, you can look at these measurements and say, yeah, wow, that saved us, this number of months of time or whatever, or this number of developers or things like that. Or previously I could deploy in 2 months, and now I can deploy in 5 minutes. So identify these metrics and then measure them. There's lots of tooling in place to measure certain metrics, but identify them, measure them, and then you can communicate them to the powers that be that make the decisions to move towards these type of architectures. And related to that, again, it's a common behavior now to not really monitor your applications until halfway through the life cycle of the application development. And instead of that, monitoring should be built in to the system from day one. So monitoring the performance, monitoring, all sorts, everything that you need to monitor, the resources, etc., should be monitored and tracked from the very first minute you deploy your first application, your first Hello World application. And then that monitoring will stay throughout the whole life cycle of the application, including in production. It'll evolve, obviously, but make sure the tooling is in place from the very beginning. And the same applies to security. Do not leave security for the last half of the development cycle. Your application needs to be fully bulletproof and secure from the second you write your first line of code. Similarly, scaling. It can be very challenging to scale an application that hasn't been designed to be scaled from the very beginning. I keep saying this Hello World application. If you're building your, if you plan to use Ruby on Rails to build up your microservice, build a Hello World. It just returns a Hello World response. And then after you've deployed that, you've got all that working, then send it, 5 million requests in the next 5 minutes or whatever, and make sure it can respond to that. Then incorporate testing for scale in your pipeline so that every time you deploy your service, it tests that it can respond to those 5 million requests properly. If you do that from when you're writing your Hello World and it evolves over time as your service gets more complex, it's much simpler than trying to scale it months down the road after there's all these bottlenecks and things in the way. You might end up having to re-architect the whole microservice in order to respond to the scale. Typically, that happens after it gets released to production and you suddenly get all these users you didn't expect. Okay. I think I've covered this enough. Fail from day one. You want to introduce failure right away and make sure you can recover from failure. Similar concept. So I mentioned this earlier too. Automation is super important. Make sure that every aspect of the deployment pipeline is automated, and do this from the very beginning. Interesting question is, I mentioned earlier that microservices allow you to build a service targeted to a specific language. So then the question is, well, if I've got this large organization, should I use, Node.js here and Ruby here and Java here, et cetera, Clojure and PHP for this other one? Does that really make sense, or does it make more sense, even though we can have multiple stacks and languages, does it make more sense to reduce these number of languages? And what I've generally heard, there's a couple of points here. One of them is that unless there's a real reason to diversify, it's probably best to limit the number of languages your company is using. It makes the tooling is more consistent, and the expertise tends to be more centered on that language. One reason that often companies are forced into polyglot world is due to acquisitions and legacy code, where you acquire another company or a team or whatever, or a product or a service that's written in another language. Instead of rewriting it, you need to support it. So you certainly, the microservices approach allows for polyglot multiple language systems. But generally, it's best to minimize those. Generally, anything you can do in JavaScript, you can also do in Java these days, or Ruby, et cetera. It's, they're all Turing complete after all. But one thing that I've found, and I discovered this at the conference this week, is that many companies are diversifying and staying on the Java VM. So Java, there's Java itself, and there's Scala and Clojure and a bunch of other languages that JRuby that can be used. And sometimes that approach works quite well as well. But anyway, the bottom line is microservices supports polyglot very well, but carefully decide how diverse you want to get with your language choices and your whole stack choices for that matter. So I mentioned earlier that with the immutable code service patterns, you can have multiple microservice versions sitting out available to be called at any time. And with that idea, it's important to have an idea how you're going to swap between these versions. Are you going to use something in your URIs for the APIs to indicate the different versions, or something in the headers if you're calling HTTP, or something else? Are you going to use tooling to swap between these different versions? let's say some sort of router in the middle that, that swaps between the versions on demand on the fly. There's many different ways to do this. The point is to keep it in mind as you're designing out your architecture, because you'll need to be able to swap between these versions based on various events over time. Okay. Empower developers. I mentioned this earlier, but you'll find that if the developers are empowered to push code to production, to acquire resources and databases without having to submit a service ticket, without these organizations kind of fighting against each other, which it doesn't sound great, but I see it all the time. The whole service desk approach actually is kind of a dangerous hierarchy in my view. It's kind of like some folks have to ask permission of other folks for a resource, and the other people might be really busy or have other things on their plate, and it might take weeks for them to respond to it, and it generates a lot of, frankly, hostility and animosity between these teams, which just is not healthy. If the developer is empowered to push to production and empowered to acquire a database instance or a VM in seconds or minutes without having to go through a process, the whole health of the organization improves. And I've seen this a few times. Very significant. Be prepared to discard. So you're going to be, to properly evolve this thing, everything's changing so quick. So, and what I mean here is you might build up a microservice using, I don't know, Ruby and Sinatra and MongoDB. And it might be working, but then you might realize that it might be much more effective using Node.js and Redis or something. So be prepared to just, rewrite it all in that second stack and throw away the first one. Don't get attached to your old code. MicroServices allows for this, so it's very, very powerful that way. Okay, identify internal proponents. This is the cultural change thing again, where it's if you're going to successfully adopt microservices, you need to measure the successes, find people inside the company that will be on board, and then communicate this out. So I'm going to something here. Oh, good. Okay, I think I discussed this earlier. Choose a small project that's amenable to that doesn't impact your bottom line, basically. But I'd like to move on a little bit. And this was something that was really obvious at the Cloud Foundry Summit this week. Almost every organization I talk to, and I talk to a lot, are recognizing now the importance of tooling for making this work. You can't just start with you can't successfully start with just a raw infrastructure and get a full microservices deployment working properly. All the things I've mentioned, which include automation, scaling, securing, failing fast, the routing and the versioning, there's many aspects to this, which if you just start with the infrastructure, you're going to be rolling a lot of that stuff yourself. So how to auto-scale your application, how to respond to events when things slow down to add new instances of your application. Wiring up monitoring tools, dealing with logging, distributed logging across the network, getting all these logs, making sure the logging agents don't fail, making sure disks don't fill up. You could spend weeks, months, years just dealing with all the plumbing of that. Even with you have Docker and containerization and infrastructure as a service, all that stuff's helpful to do all this, but you're still doing a ton of work keeping everything working right. And the natural evolution is the tools are evolving to handle all this for us, and that's where platform as a service comes in. I'm going to spend the last, I think I've got about 2 minutes here. Let's look at a few of the features of platform as a service that do enable this whole microservices approach. There we go. So I'm going to run through these really quickly, but a platform as a service, and there's several available today. The most popular ones are based on Cloud Foundry these days. And some of the features that it provides that facilitates microservices are the ability to manage multiple clusters of systems for you, VMs or whatever, on which your applications will run. They have a lot of facilities for failover and resilience, availability, dealing with routing between services, load balancing between services and applications. A lot of automation just comes with the PaaS, so that you don't have to be building that and rolling that all yourselves. I mentioned earlier the importance of having consistent environments between dev and prod and production and staging and all that, and a PaaS will greatly facilitate that. So in other words, if you use a PaaS, it guarantees that each one of those teams has an absolutely identical or very close to identical environment as possible. Not all just comes for free. PaaS enables the self-service concept of the cloud, meaning that the developer team can go to basically call an API or use a user interface to request something like a VM and an app and a database schema to be managed, etc. The self-service is a very important part of this whole cloud evolution, really. Platform as a service will enable scaling out of the gate, basically scaling from day one, like I mentioned earlier. So when you deploy your app to the PaaS, it can handle spinning up new instances of your app as the load increases and the response slows down as new users start accessing your application. So as I said earlier, trying to roll that yourself would introduce a lot of extra work and time to get your app out the door. Let's see what else. Oh yeah, we talked about versioning of services, and that's built right into the PaaS where you can roll back and roll forward your versions. It handles the versions for you. If there's an error or a problem with the new version you roll out, you can just, at a click of a button or a call of an API, roll back to your previous version. Any PaaS will support multiple languages, Java, Ruby, Python, Node, etc. With no configuration, no downloading of packages, no maintaining of all that. PaaS will support monitoring and logging. Right out of the box, apps will be logged and monitored. Can manage, have hooks into databases and other services that you might use with your application, so you don't have to configure and load those. It takes care of a lot of dealing with the credentials and location of your external services you're accessing, discovering of services. It helps with this immutable service patterns we talked about as well with the versioning, etc. So there's a lot of things that PaaS takes care of with microservices. I work for ActiveState, and we have a platform as a service called Staccato, which is what I focus much of my time on. But I do want to emphasize it. The Cloud Foundry Summit this last couple of days, I talked to dozens of organizations that have kind of seen the light with PaaS, or at least with tooling for microservices. They've realized that it cannot be done without having some powerful tooling like this in place. So I'm going to, I have tons more slides, but I need to just call these two things out. We have a webinar tomorrow that I recommend you attend, discussing the new version of Staccato, which is incorporated Docker apps. Very cool feature if you want to see it. And I also want to mention that we'll be at OpenStack Summit next week in Vancouver. That's where ActiveState is based, so obviously we'll be there. I'll be there. I'll be giving an extensive talk on Cloud Foundry on OpenStack and going right into the details of using it. So I apologize for rushing here. I had a lot of content. I hope everybody has enjoyed this webinar, and I'll look forward to seeing you on the next one. Thanks a lot.